Hello everybody. Today we are going to work through homework 3 and we start with exercise 1, which is the absolutely longest one. So let's just begin. Let x1, x2, xn and y1, y2, yn be random variables as usual. We have xn bar, the mean of the x's, equal 1 divided on n, the sum over I equal 1 to n xi, and y bar m equal 1 divided on m, the sum I equal 1 to m yi. Additional, let set 1 be equal x1, set 2 be equal x2, set n be equal xn, comma, set n plus 1 be equal y1, comma, set n plus 2 be equal y2, comma, comma, set n plus m be equal ym. So here we have the notation we're going to use through the exercise. And in A, we are asked to show that 1 n xn bar is equal the sum I equal 1 to n xi, and 2 that m bar is equal m sum yi, I equal 1 to m. Okay, we just start with what we are given, nxn bar, so we're starting with 1, nxn bar, that's of course equal n, and how can we write xn bar otherwise? That is x1 plus x2 plus xn divided on n. So this is xn bar, and then we can take n against n, and we have nxn bar is equal, and then we see we have x1 plus x2 plus xn, but that's actually the sum of the xi's, so that is sum I equal 1 to n xi. So let's do the second one, which is totally equal. Here we have m y bar m, and then instead of writing ym bar, we can write m is m, and times we have to add all the y's, and we get y1 plus y2 plus plus ym divided on m, and then m and m cancels out, and we have ym bar equal y1 plus y2 plus ym, and we see that ym bar is equal the sum because this is nothing else but a sum from I equal 1 to m yi. And here is this, the sum. Okay. That was the start away, and then we have to we shall then use the sum I equal 1 to n xi minus xn bar equal 0. So show 1 that this is true. So then we have to let's show this. It's a lot of ways doing this, but I think I will do it the hardest way. And that is writing out the sum. That is xn minus xn bar plus x2 minus xn bar plus xn minus xn bar. And then we can rewrite, so we get x1 plus x2 plus xn, and then all the xn bars here, xn bar minus one more xn bar minus dot 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 minus xn bar. And then we see that this is nothing else but the sum over the xi's, I equal 1 to n. And here we have xn bar n times, so that is minus n xn bar. But now we have just concluded above that this sum xi is, if you look up here, we know that this sum xi can be written as n xn bar, and here it's n xn bar, and that's of course equals 0. And likewise it will be when we are going to show that the sum I equal 1 to m yi minus ym bar is equal 0. So then we just write out the sum. So we have that sum I equal 1 to m yi minus y bar m. That's equal y1 minus y bar m plus y2 minus y bar m plus dot 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 plus ym minus y bar m. And then we have y1 plus y2 plus ym minus yn bar minus yn bar m for Martin, m bar minus y m bar. And this is nothing else but the sum over the yi's from I equal 1 to m and minus m of ym bars. And then we have this first term, the sum over the yi's, we have showed here. The sum over the yi's is equal m y bar m. So I just fulfill this, use this down here. So this one is my m bar, and we have my m bar, and that's of course equal 0, what we was supposed to show. So I just put in this sum xi minus xn bar I equal 1 to n. Okay. So then we can go to B. Convince yourself. Okay. So here we are going to sum over I equal 1 to here it's some notational wrongness in the homework you have been given, I can see. So but you may have understood that, but anyway, here it should stand m plus n set I, which is equal the sum of I equal 1 to n xi plus the sum I equal 1 to m xi yi. This is what is correct. It must be like this. And why is this correct? Well, let's see. Let's convince ourselves. I equal 1 to m plus n is actually equal, set I is actually equal set 1 plus set 2 plus set n plus set n plus 1 plus set n plus 2 plus set m. And then we can see that this is actually the same as the sum over the xi's, I equal 1 to n, and this is the sum over the yi's from I equal 1 to m. This we got from the introduction to this exercise. Here you see that set 1 is x1, set 2 is x2, set n is xn. And set n plus 1 is y1, and so on until set n plus m is equal yn. So therefore this makes sense. And we have convinced ourselves. So then it's C. Derive an expression for. So now we have to find this expression for the mean of the sets. So let's do that. We know that the means of the sets is equal 1 divided on every set times the sum over all the sets. So we sum all the sets and divide on how many sets it is. And it's actually n plus n. But now we know that this can be written as 1 divided on n plus m. And we just showed that the sum set I, this one, is actually nothing else but the sum I equal 1 to n xi plus the sum I equal 1 to n yi. This is from exercise 1b above. Yes, and then it's then we use exercise 1a. We know that the sum of the xi's is the same as n x bar n. And this next term, the sum over the yi's is equal m y bar m. This we showed above. Let's look at it. Here we showed it, the red lines. We see that the sum xi is equal nx n bar, and the sum yi is m y n bar. So going down, we can see that we have replaced the sum xi's with the nx n bar and the sum yi's with the m y n bar. And then we actually got the result, because then we just can multiply and we get nx n bar plus n y n bar divided on n plus n, which we was supposed to show. Or what we was supposed to derive. And then we have D. Now we are asked to explain when will the formula derived above be equal one half, or we can write it like this, set n plus m bar equal 1/2 xn bar plus yn bar. Well, that will be, if you stirring at the formula here, we can see if n is equal m, then this will be true. n has to be equal m. Okay, let's take an example. This is true. This is true when n equal m. Let's say n equal m equal s, for example. So then I replace in the real big formula the set n plus m bar, which is n xn bar plus m yn bar divided on n plus m. So if n is equal m, let's say s, then we have set bar s plus s is equal s xn bar plus s yn bar divided on s plus s, which gives, if we factorize s outside, s xn bar plus yn bar divided on s plus s, that should be 2s. Then we can cancel s with s, and we get the result. This is nothing else but a half times xn bar plus yn bar, which we was supposed to explain. So n has to be equal m. That is the essence here. Then we can take e. So here let's write that first. Remember, sx in the power of 2, the empirical variance, is equal 1 divided on n minus 1. The sum, oh, I see I write n here, that should be m, but then everything is okay. So remember, sx in the power of 2 is equal 1 divided on n minus 1. The sum I equal 1 to n xi minus xn bar in the power of 2. So that's the normal empirical variance, and for the y's we will have the empirical variance as 1 divided on m minus 1. The sum I equal 1 to m yi minus ym bar in the power of 2. So this is what we know. And S sets and the empirical variance of the sets is similarly defined. We will study that later. Similarly defined. Okay. So show that the sum I equal 1 to n xi minus x bar n. No, sorry. Show that xi minus a in the power of 2 is equal n minus 1 times sx in the power of 2 plus n xn bar minus a in the power of 2. So this is what we are going to show. And we get a hint, and that's very important to use here. That is on the next side, but the hint is as following. The sum xi minus a in the power of 2, I equal 1 to n is equal sum I equal 1 to n xi minus x bar n plus x bar n minus a in the power of 2. Why is this correct? Because we haven't added anything actually. We have subtracted xn bar and added xn bar, and that's actually like adding 0. So we can just do this. So let's now then do this. So now we're going to show what we are asked to do. So we start with sum I equal 1 to n xi minus a in the power of 2. Okay, and we use the hint. So we use that this is equal to sum I equal 1 to n xi minus x bar n plus x bar n minus a in the power of 2. And then we can think of this as 1 and this as 1. And remember from high school that if you have something, for example, x plus y in the power of 2, this is the first in the power of 2, plus this is the first square sentence, x in the power of 2 plus 2xy plus y in the power of 2. But now x is xi minus xn bar. So here we get this equal using the rule on the right side in red. Xi minus xn bar in the power of 2 plus 2 xi minus xn bar minus a plus xn bar minus a in the power of 2. Okay. Just use this red rule. And then we have to be a little smart. We can put this sum inside the parentheses. So first I write the sum I equal 1 to n xi minus xn bar in the power of 2 plus, and then I see that 2 is okay, I will do it slow. So then we have sum I equal 1 to n 2 xi minus xn bar minus a plus the sum I equal 1 to n xn bar minus a in the power of 2. So now manipulating a little here. Nobody can deny me to do like this. Okay, let's first write I equal 1 to n xi minus x bar n in the power of 2 plus, and then I take out the constants because that we are allowed to do that handling sums. So 2 xn bar minus a, that is just constant, putting them outside the sum, and we got I equal 1 to n xi minus xn bar plus and actually this last one is just a sum over a constant. So this is nothing else. So we could actually take the constant out, xn minus a in the power of 2, that's a constant. Sum I equal 1 to n, given data, n, and we put 1 there, because we've taken everything out. And then we know that this one is equal 0 from exercise, where did we find that? From exercise here. Here we show that this is 0. This is 0. We have showed it. That's exercise 1a. So going down. Equal 0 from exercise 1a. And if I now use a little trick, which is not so very easy to guess maybe, but like this, n minus one times 1 over n minus 1, then I have the, not, this is just multiplying with 1. I can do that in front of this sum without changing anything. Like this. Plus, and this is then 2 times a constant times 0. So, okay, let's write it. Xn bar minus a times 0 plus, and here we have then this constant xn bar minus a in the power of 2 times, and we sum 1 n times. That's actually the same as n. 1 plus 1 plus 1 plus 1 plus 1 n time is n. This is then 1 plus 1 plus 1 plus dot 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 plus 1, which is equal n. And then we have the answer, because now we can see that this is sx in the power of 2 from the definition, and I have now then this n minus 1 in front, plus 0, plus n xn bar minus a in the power of 2. Okay, once more without the 0, and this was what we was supposed to show. With all the steps. So then we can do a little tricky exercise, the F. This is a heavy much notation, and I think a lot of you will find this difficult. But I will do it anyway. Maybe not talk so much, just do it. But I do all the steps, so if you really want to understand it, you can do it. And if you don't understand it when I'm doing it now, you come to the day where we have where you can ask questions, or in the office hour, and you will have the answer. Or yes, you will get help to understand. So okay, we got in F, we are asked to show this will take some time. Show that S set in the power of 2 is equal n minus 1 sx in the power of 2 divided on n plus m minus 1 plus m minus 1 times sy in the power of 2 divided on n plus m minus 1 plus nm xn bar minus ym bar in the power of 2 divided on n plus m minus 1 times n plus m. Okay, these are what we're going to show, and we will do it now. We have to start with the formula for s set in the power of 2. The sets. Okay, what is the formula? Yes, that's we have to sum over all the sets, and first divide 1 divided on n plus m minus 1, because we have n plus m sets. So this is just the formula for empirical variance, which I'm using for the sets. I equal 1 to n plus m. Set I minus set n plus m bar in the power of 2. And now we have to, it's many things we can do, but we start like this. So then we get 1 divided on n plus m minus 1. And I just split the sum first by doing like this. I equal 1 to n. Set I minus set bar n plus m in the power of 2 plus the sum I equal n plus 1 to m set I minus set bar n plus m in the power of 2. And then we have that this is 1 divided on n plus m minus 1, parenthesis. And when I goes from 1 to n for the set i's, we know that the set i's is equal the x i's. So this is nothing else but the sum I equal 1 to n xi minus the constant set bar n plus m in the power of 2 plus, and when the set I goes from n plus n to m, we know that this is actually the same as I equal 1 to m for the y i's minus set n plus m bar in the power of 2. Okay, so far so good. And now we have to use the result from E. So we have to use, so okay, here split sum, replace set I, and now we are going to use result from exercise 1E. So remember result 1E, that is, let's find it, that is the sum that is the sum I equal 1 to n xi minus a in the power of 2 was equal n minus 1 sx in the power of 2 plus n xn bar minus a in the power of 2. This is a result, so now I'm using it, and then we get a set in the power of 2 equal 1 divided on n plus m minus 1, and then we see that this one plays the role as this one. So then we can write this sum otherwise, and I just do it now. So then we get following. N minus 1 sx in the power of 2 plus n xn bar minus the constant, which now is set bar n plus m in the power of 2. And then we have to do exactly the same for this one, which also follows result 1e. So we have to use result 1e here, and we have to use here. So that gives us plus, no, it's m minus 1 times sy in the power of 2 plus m yn bar minus set n plus m bar in the power of 2, and then n parentheses. And now it's a lot of manipulation here, and we will do it. So now I actually will multiply this inside the parenthesis. So then we get s set in the power of 2 equal 1 divided on n plus m minus 1 n minus 1 sx in the power of 2 plus n over n plus m minus 1. I can more easily write n minus 1. So plus n divided on n plus m minus 1 parenthesis xn bar minus, and then we have to take this set n plus m bar, but that we know is the same as n xn bar plus m yn bar divided on n plus m, like this, and plus m minus 1 sy bar plus m yn bar minus set n plus m, so which is n xn bar plus m yn bar divided on n plus m in the power of 2. And here we have to not forget n plus m minus 1, and here neither. n plus m minus 1. So actually, what have we been doing here? We have multiplied this one into the parenthesis. Therefore, we get n minus 1 over n plus m minus 1 as x in the power of 2. And here we also multiply this one inside here, which gives n over n plus m minus 1. And then xn bar minus, and I then replace set n plus m bar with, we got that here. We found this earlier today. So going down here, we see we just have replaced this here. And then we multiply this one inside here too, and we get m minus 1 over n plus m minus 1 sy in the power of 2, and m over n plus m minus 1 times ym bar minus, and again replacing set n plus m bar with n xn bar plus m ym bar divided on n plus m. And then we do as following. So let's write here, above we used that set m plus n bar is equal n xn bar plus m ym bar divided on n plus m, like this. So then we can continue manipulating. So now we will do like this, n minus 1 divided on n plus m minus 1 as x in the power of 2 plus n over n plus m minus 1. Or actually I wanna just take this plus m minus 1 over n plus m minus 1. I can take this first, sy in the power of 2. And so then I just took this one here and this one there, and now I go take this one. So then we have n over n plus m minus 1, and we get xn bar, and I times here with n plus m, and we then get minus, we can have one extra, so, and n plus m here, just expanding, minus n xn bar plus m ym bar divided on n plus m, plus m over n plus m minus 1, and now is it y bar m, which we have to times with n plus m divided on n plus m minus n x n bar plus m y m bar divided on n plus m in the power of 2, and in the power of 2 there too. And then we get set in the power of 2 equal and we multiply this last one too, where we get m over n plus m minus 1 times ny m bar plus my m bar minus nxn bar minus my m bar in the power of 2 divided on n plus m. Like this. And then again, adjust this one plus this one once more. I don't write it. And then we see that this one goes against this one. And this one goes against this one. So we got, doing it slowly, plus n over n plus m minus 1 mxn bar minus mym bar divided on n plus m in the power of 2 plus m divided on n plus m minus 1 parenthesis. And actually, to be a little faster, I will factorize. You can see that this one and this one have m in common, so I factorize m outside. So I write m xn bar minus yn bar like this, plus what I've written, and then I factorize. And now I do a little trick. I factorize not n, but I factorize minus n outside. And then I actually get xn bar in a positive way and the ym bar in a negative. Because if I now multiply inside again, I will get what I have factorized. So this is the same as what stands above. That's a little trick. You may see it like that. And then we have this, plus, and now let's write this as m in the power of 2 times xn bar minus ym bar in the power of 2 divided on n plus m bar in the power of 2 plus m over n plus m minus 1 times, and then minus n in the power of 2 is actually n in the power of 2, xn bar minus y m bar in the power of 2 divided on n plus m in the power of 2. So that's fine. And now we can do the last math here. This the same, plus, and we have n over n plus m minus 1. And actually we got n plus m minus 1 both here and both there. So I put that outside a parenthesis. Okay, we'll take one more step here. So I actually write we can see we have the same numerator in both the two last terms. We have the same numerator here and here. Here's the first term and here's the second term. And therefore I can put all on one fraction. So this will be plus n m in the power of 2 x n bar minus y m bar in the power of 2 plus m n in the power of 2 x n bar minus y m bar in the power of 2 divided on n plus m minus 1 n plus m in the power of 2. I don't say it's easy. Set s set in the power of 2 now is equal this plus, and now I factorize everything I can outside a parenthesis. I see I have one n here and one n here. I have one m here and one m here, and I have all this x n bar minus y n bar in the power of 2 on both sides. So all this I put outside a parenthesis, so I then get n m x n bar minus y n bar in the power of 2 parenthesis just an m in the first one plus just an n in the second term, which remains, divided on n plus m minus 1 n plus m in the power of 2. And then we can see that we can cancel out one of this with one of this, and we have the desired result, which is that the empirical variance of the set i's is equal to n minus 1 divided on n plus m minus 1 sx in the power of 2 plus m minus 1 divided on n plus m minus 1 sy in the power of 2 plus nm x n bar minus y m bar in the power of 2 divided on n plus m minus 1 times n plus m, which was what we were supposed to show. And now we are going to do a last thing. We shall in Python check that the empirical variance of the set i's can is the same as this right side, and this right side just uses the x's and the y's and don't care about the sets, if you can say it like that. So that's G Python we will check that s set in the power of 2 is calculated correctly implementing the right side. Okay, let's go to Python. So we do that like this. Here is Python, and here we got the code from the text which you have been given. So that should just copy and paste. So I believe you have done that, and then we have to see what this code says. Here we have n, a special case for n equal 83, so that the length of x vector, and m is 12, that's the length of y vector. So we have a lot of more terms in the x vector than in the y vector. And then we draw randomly n standard normal distributed numbers and store them in x. And here in this in line 12, we draw randomly n standard normal distributed numbers and store them in y. And we also make the set, which is just to combine the x's and the y's in one single vector. And that's what this